Hello guys, and welcome back to Joe's Ventures, and today we're doing part 94 of our Jurassic World Evolution 2 mod spotlights, where we take a look at some of the wonderful mods people are making and compare them to their real-life fossil counterparts. So today we've got quite an interesting assortment. We've got quite a few dinosaurs today, but also quite a few mammals and an ichthyosaur, so I'm quite excited to get stuck into this one. But we're going to be starting off today with a really cool animal. We've got Stegoceras, done by Glitch and Trip. So let's have a look at this guy. So let's have a look at this guy. Let's have a look at one here. Let's see let's pick one. So many wonderful colors that come in. We'll have a look at you. I like this one. So this is Stegoceros, not to be confused with Stegosaurus. So this is a genus of pachycephalosaurid or dome-headed dinosaur that lived in what is now North America during the late Cretaceous from about 77 to 77.5 to 74 million years ago. And the first specimens came from Alberta, Canada. So the first remains were found by Canadian paleontologist Lawrence Lambie from the Belly River Group in the Red Deer River district of Alberta, Canada. And that consists of two partial skulls from animals of different sizes and a third partial dome that was collected in 1901. And Lambie described this new monotypic genus as the species Stegoceros validus, and the generic name for Stegoceros means roof horn, and validus means strong, so yeah, quite strong. And because the species is based on multiple specimens, it was given a lectotype as well. There'd been no similar remains found in the area before, and everyone was like, what the heck is this thing? Everyone thought it was some kind of cool dinosaur, unicorn dinosaur. And there were uncertainty whether it belonged to the ceratopsians, or the horned dinosaurs, or plated dinosaurs, stegosaurs. Kind of figure out where it was. And in 1918, there was a couple new specimens described, and at that point, he considered them members of Stegosauria, and a new family he called Pelorosauridae, but we'll get into what taxonomy there. In 1924, they actually found a complete skull along with some postcranial remains, and the reason we know so much about Stegoceros is because of these remains, because it's basically the most complete remains of a dome-headed dinosaur. So Stegoceros is actually quite important understanding of pachycephalosaurs because they're normally quite scant. So this is the most complete species known, so it really is important to understand these guys. And looking at things like Australia, and which is actually not known in any other siskin dinosaurs, and they actually found that their teeth was quite similar to those of Troodon. So at a time, they considered Stegoceros a junior synonym of Troodon, which is obviously a troodontid, and which is a saurischian dinosaur, a theropod, which is not a pachycephalosaurid ornithischian dinosaur, which is quite interesting. And so they were considered the same, and also some point they was going to be a nothosaur, which was really interesting. And there was a couple other species described from this time, like 1940s, Sternbergi and Montonius, and then T. wyomingensis, which was actually lumped into Pachycephalosaurus. And they found validus, Troodon validus distinct from Formosus, and then kind of came up with Stegosaurus, so it was valid again. And I mentioned a couple other species that were kind of lumped into it. And in 1953, there was actually Troodon belexi, which was discovered in China, which was found to be a species of Stegoceros, which is Stegoceros belexi, and then was kind of brought into its own genus Ornitholus as well. So they mentioned Ornitholus, and was considered the first known American group of those flat-headed pachycephalosaurs that were previously known from Asia. But we'll get into things. This is very interesting because the taxonomy of pachycephalosaurs is very confusing, as we'll get into. So in the 2000s, we're moving into the 2000s now, the 21st century, they referred Edmontoniensis and Brevis into Prenocephaly, which was at the time only known from a Mongolian species, and found that belexi was actually belonged to Prenocephaly rather than Stegoceros, which made it dubious. And they considered Ornitholus, which was another smaller species of Pachycephalosaurus, a nomen dubium, and actually a juvenile of Stegoceras. So because of now we know that domes grow as they get older, a lot of species, a lot of genera that were considered previously species are now just juvenile or adult forms of other previous genera that were named. And because Stegosaurus was named first, other than Ornitholus, that gets precedent. And then there was a Lambi that was considered moved to the genus Copanocephalae, and Sturbergi to Harnesia, and they kind of Stegoceros became a waste bucket taxon. And a few other species were originally species Stegoceros that were moved into their own genera, like Forminicocephalae, Cynocephalae, and Gasosaurus, which is quite interesting. And there's been more and more kind of describing domes that could be juveniles, things like that. And there was actually a new species in 2011 potentially described, Nova Mexicanum, when it's kind of talk about as well. In 2016, they restudied the holotype for that one and actually did not map in all the individuals juveniles, so it could be either a juvenile Stegoceros or Spagatholus, another well-known, previously known Pachycephalosaurus. It could just be babies. So it's really difficult to identify them as adults, but they're most likely juveniles. And in 2024, there was even a specimen of Stegosaurus found in the Jula Formation that was assigned to Stegoceros, and it's juvenile, very comparable to the juveniles of Validium, and could be a new southern species of Stegoceros, but not Nova Mexicanum. And then there's a lot of taxonomy, as I mentioned. That's basically the rundown. I've given you the rundown of the taxonomy. Be able to talk about the description. So Stegoceros is actually one of the most completely known North American pachycephalosaurs, and actually one of the few known from postcrania. Validium is the most complete Stegoceros individual known to date, which is UALVP2. It was estimated to be about 2 to 2.5 meters in length, and approximately the size of the goat, about 10 to 40 kilograms, and was considered small or medium sized compared to other pachycephalosaurs. Novacanum appeared to be smaller, but because it's potentially juvenile, we don't really know. Yeah, you can see the skull of these guys. Very triangular skull, quite boxy though as well. And you can see there's definitely adult. You can see that dome going on, and you can see that kind of like ring of bones around the tubercles around the back, or the knobs you can kind of see there, with a large orbit, which suggests they have a big eye. And they have heterodontites. As I mentioned, they were quite similar to the ones of Troodon. So Troodon, they had relatively sharp, small teeth, with the rows did not form a sharp cutting edge, but they did overlap, which is quite interesting. The skull can be distinguished by other pachycephalosaurs as the pronounced parotosquamosal shelf that becomes smaller with age, and then that doming. So the dome grew as it got older, so that's why the taxonomy of pachycephalosaurs have got much more confusing, because a lot of ones that were originally own genera are now younger species or just younger individuals. But we do have a pretty good idea of how they looked behind the head as well. And which is really interesting, have a caudal basket on the tail, which consists of parallel rows of tendons, which is actually not seen very much it's actually seen in teleos fish, and this is actually unique to pachycephalosaurs among tetrapods or four-limbed individuals, and would have functioned to stiffen the tail, which is quite interesting. So as we talked about classification, they were originally described in the group Ornithischia, which is Paracephalosauria, and kind of figure out where they were. They were originally split into two different kind of families, Pachycephalosauridae and Homalocephalidae, which included the dome-headed and flat-headed pachycephalosaurs respectively. And by the 1980s, we were starting to actually figure out what they're kind of related to, and then 1986, Paul Sereno suggested the relationship between pachycephalosaurs and ceratopsians and united them in the group Marginocephala, so it seemed to be quite similar. But by the early 21st century, not a lot of the pachycephalosaurs were known from postcranial remains, and many are only known from domes, so that makes the taxonomy quite difficult. And as I mentioned as well, since some have potentially the flathead ones could be babies of the dome-head ones, neither here nor there were some flathead ones. It's kind of all over the place, so it's kind of hard to tell the exact taxonomy. But we kind of know that Pachycephalosauridae had Stegoceros in it, and then Pachycephalosaurines was kind of the later group, so a little bit more basal in that group as well. But yeah, they would have been found in North America and Asia, the Pachycephalosaurs in general. But it's unknown where they first originated, but these guys were kind of a bit earlier. They're from the Middle Campanian, and Homocephalae was from the early Maastrichtian, so about 77 and 70 million years ago. So the doming could potentially be a form of convergent evolution within the group, or represent ghost lineages, or probably just a taxonomic bias. Because they're smaller, we just don't have those fossils yet. But yeah, it's uncertain what Pachycephalosaurs ate. Looking at the teeth, there was a lot of people that suggested they would have eaten a mixed diet of leaves, seeds, fruits, and insects. But Stegosaurus had teeth very much like those of iguanid lizards, so potentially could have been much more herbivorous. Though you could make the argument, bearded dragons and things like that, they're omnivorous, so whatever. The optical region of Stegoceros had well-defined muscle attachments, so they could move their jaws up and down, not side to side like a cow. And they actually had a look at Thescelosaurus as well as Stegoceros and looked at kind of the marks that they made in their teeth. So Thescelosaurus was more of a selective feeder with this narrow nose, being able to pick more selective plants, while these guys were indiscriminate bulk feeder that ate a large amount of vegetation with their big bulky bodies. And looking at the endocasts or the fossil kind of imprints of their brain as the mud gets in their brain case, they actually suggest they had quite a large olfactory bulb, which means they had quite a good sense of smell. Very similar to like that of a turkey or an ostrich, and they would have been able to smell quite well, which is really interesting. As I mentioned as well, we do have a growth series actually for Stegoceros. There was a lot of things suggested that could be, sexual dimorphism, as the flat-headed specimens could be the female morph of Stegoceros. But what we kind of see at the moment is that they all would have been, it would have been something in both males and females, so it'd be very hard to tell apart. In 2003, Williams and Nicard actually produced a hybrid hypothetical growth series using Ornitholus' juvenile stage. So the juveniles would have had a flat head, and then would have grown the bulb over time, or grown the boss over time, which is quite interesting. In 2011, they actually did a much more comprehensive analysis of this, and they actually found some bones actually decrease in size, and actually a lot of evidence does support Ornitholus being a juvenile Stegoceros. So yeah, that idea of the along with like Stygimoloch and Dracorex and stuff being younger Pachycephalosaurus, that all kind of goes to the point that this would have been something growing over time. So it seems there's going to be a lot of lumping of Pachycephalosaurs because a lot of them may just be babies. So that's quite cool. And there's been a lot of debate how their domes would have functioned. The function of the dome has been suggested to use for interspecific combat, sexual display, or species recognition. So the most likely one would have been combat, since we do have injuries and adaptations that suggest they would have been able to take forces when they bumped into each other. They actually, the impact would have been absorbed by neck ligaments and muscles to prevent injuries to the skull. And there's actually injuries on Pachycephalosaurus skulls that suggest they were hitting each other, dome to dome, but also they could have been each other flank to flank, which is quite interesting. Some others suggest that they may have been quietly coloured as threat displays, which could obviously be both too, because these dinosaurs see in colour. You could have a bright dome, which is interesting as well. And yeah, a lot of them would have been covered in thick keratin, and they would have been able to distribute the impact, very similar to those of like bighorn sheep, duikers, and giraffes. The keratin would have been helped disperse the impact, and just the harder skull. They have a lot of adaptation to the skull, very similar to things like bighorn sheep and bovids that use their skull a lot for fighting, so there's a lot of convergent evolution there. And they actually believe that their stiffened tails may have actually been not used in defense against flank butting, but enable them to have a tripodal stance during interspecific combat, so they can use the tail as support. So that's a very interesting kind of concept. And as I mentioned, lesions have been found on many Pachycephalosaurus skulls, but were absent in flat-headed specimens, was consistent for intraspecific combat or compete within members of the same species. And that makes sense because obviously the babies aren't going to be headbutting in the same way the adults are, so you'd see the injuries in the adults but not the babies, which we kind of see there. So that's kind of a way that we can say, it's much more of a sexual display thing, or sexual thing. And there's actually some, looking at the Fossils or the hind limbs, the forelimbs and the hind limbs of the species is the forelimbs would be much more conservative, much similar to early biped saurischian dinosaurs, but their legs would have been much more advanced, so they would have had quite a strong, stable pelvis structure to help with during the headbutting, and they would have had much more developed legs, and that would have been propelled them for their headbutting. So that's quite interesting there. Other suggestions has been heat exchange with the honeycomb structures, potentially having a lot of blood vessels that could go up there and could be for heat exchange. Species recognition, which is another thing, which is kind of not really a thing. And sexual displays and things like that, but definitely headbutting would have probably been the most likely one. But again, the paleo environment this guy was found in is in the late Cretaceous Valley River Group, which is the Canadian equivalent of the Judith River Group, and has been recovered from the Dinosaur Park Formation, Dinosaur Provincial Park, and the Oldman Formation in Canada. So quite a wide range, and the other species have been known in the Fruitland and the Kirkland Formation. But they would have lived in very interesting habitats with all sorts of cool dinosaurs. The Dinosaur Park Formation is very famous. It would have had dinosaurs such as Centrosaurus, Styracosaurus, Chasmosaurus, Prosaurolophus, Pachysaurolophus, Corythosaurus, Lambeosaurus, Gryphosaurus, Edmontonia, Eopcephalus, Gorgosaurus, and Daspletosaurus, and a lot of other really famous dinosaurs. The Old One Formation has ceratopsians like Coronosaurus and Albertoceratops, ornithomimids, therizinosaurs, Brachylophosaurus, troodontids, oviraptorids, dromaeosaurs, and potentially tyrannosaurs. So it would have been a very rich formation they would have been living in, which would have been, of course, quite cool. So we're going to be moving on now. We've still got Glitch and Trip doing stuff with us. So let's let them run off and do their thing. We have got, this is part of their kind of double pack, so they got a ceratopsian bundle, which they called it. So I've got here Diabloceratops. Here it is. Which one should we pick? Let's pick this one. I like this one. There we are, we'll pick this one. We just pose it, and there we are. So this is Agujaceratops, which means horned face from Ajula. This is a genus of horned dinosaur from the late Cretaceous, or the Campanian of West Texas, and is a chasmosaurine, so is a long-frilled ceratopsian, related to things like Chasmosaurus and Triceratops. And two species are known, Margicelius and Marvanitas, I believe you say that. In 1938, 3 fossil beds were found from the Big Bend National Park in Texas, and they were first referred to as a species of Chasmosaurus, which was known from the holotype, which is a partial skull, and then additional material had been found and considered to be part of it. And all specimens come from the lower part of the Ajula Formation, which dates back to 77 million years ago. And then other specimens were recovered additionally elsewhere in West Texas, with a nearly complete skull actually coming from Rattlesnake, Montana, which is quite cool. As I mentioned, it was originally described as a Chasmosaurus species in 1989. Subsequently, was in 2006 was considered to be its own genus, which is Agujaceratops. And then later they found some variations. So the skull that was found at Rattlesnake Mountain Skull is now considered a new species, Marvanitas, I believe you say that. Alright, so in terms of its description, it was a relatively large horned dinosaur, reaching about 4.3 meters or 14 feet in length and about 1.5 tons. It was similar to other chasmosaurians such as Pentaceratops, as having a short nose, horn, long brow horns, and elongated frill with small hornlets. The back of the frill had a strong notch, as in Pentaceratops and Chasmosaurus. You can kind of see that there, so we can see that strong notch, giving it a heart shape. So you can see that kind of heart shape going on, with 3 to 4 pairs of spine-like hornlets. The edges of the frill bear numerous low blunt hornlets, giving a strong scalloped appearance. So you can kind of see the scalloping going down along there, giving The brow horn was also oriented up and out and curves backwards in the side view. So it's got a very interesting kind of look to it. It kind of just curves up. At the time, which is interesting, two species are known, and the type subspecies has a shorter brown horn and a shorter frill. That's made a way to tell them apart. But in terms of their ecology and things like that, they weren't too different to other ceratopsians. They were four-legged plant eaters, and their elaborate frills and horns suggested they would be kind of living quite a complex social life, which includes displays towards and fighting each other and jousting for mates. Multiple individuals have been found in a single quarry, though it's unclear if it's a drown event or a flood event or herds. Although it's common to find centrosaurine ceratopsids together in large bone beds, animals like Centrosaurus and Pachycephalosaurus have been found in large groups. The bone beds are a little bit rarer for chasmosaurines. And at the time, these guys would have lived along the margin of the Western Interior Seaway, which was a big seaway that divided America into two. And the habitat lived in would have been much more swamps, depending on the sediments. And it would have lived with a very interesting assortment of animals, including a feathered dinosaur called Leptorhynchus gladzi, a small Pachycephalosaur Texocephaly, and predators would have included tyrannosaurs, and actually Dinosuchus riogranensis, which is a very large alligator, with crocodilian. They would have lived there with it. Yeah, that's the first of our bundle, also done by Glitch and Trip, and this one's also done by Glitch and Trip as well. We got Diabloceratops. Alright, so that's Diabloceratops this time. So let's have a look at these guys, and of course it happens. There we are, that's better. So let's quickly find one that will pose on. We'll pick this one. No, this one. This is Diabloceratops. Alright, Diabloceratops is an extinct genus. This is a centrosaurine this time, so you kind of see the difference between chasmosaurians and centrosaurines. They lived approximately about 81.4 to 81 million years ago during the late Cretaceous of Utah. It was a medium-sized quadrupedal herbivore, was estimated to be about 4.5 meters long and about 1.3 tons in mass. And at the time of discovery, it's actually the oldest known ceratopsid and first centrosaurine known from latitude south of Montana. So that's kind of its claim to fame. The generic name Diabloceratops means deviled horned face, as Diablo is Spanish for devil, and Ceratops is Greek for horned face, which is quite interesting. And the only specimen found was at Lance Chance Creek in the Waiweep Formation in Kane County, Utah, and it was discovered in 2002 and was found in sandstone deposited during the Campanian, which is a strategic level of about 81 million years ago. It consists of a partial skull and a piece of a lower jaw, with the right side being intact. Another specimen was also discovered in 1998 from the same formation, was not described, and then assigned Diabloceratops. However, this specimen may not just belong to Diabloceratops because it shares features found in more derived centrosaurians. And research actually found it's more similar to Agujaceratops, Ceratops, and Moeritherium, which is interesting as well. So in terms of its description, medium-sized ceratopsian, about 4.5 meters or 15 feet long, and a little over a ton, 1.3 tons. Built very similar to most ceratopsians, their bodies don't vary too much, and that it had a large neck frill made of bone. It also had a small horn on its nose, perhaps the second horn in front of that, and a pair of small horns across the eyes, and its skull was actually quite deeper and shorter compared to other centrosaurians. And upon the frill, it had a pair of very long spikes here, like as in Stegoceras and Neosaurus, and as one of the earliest centrosaurine ceratopsians. They actually share a lot of traits with things like proceratopsians, like Protoceratops as well. And both actually possess an accessory opening to the skull, which is much more reduced and disappeared later in much more base or derived ceratopsians, um, which is really interesting as well. And you can see it's kind of bucks the trend for centrosaurians. Usually they have a big nose horn. These guys have got slightly bigger brow horns, which is interesting. And as I mentioned, they are considered quite basal. So they are kind of quite basal to Centrosaurine. They're right at the bottom, and then there's Moeritherium kind of closely related to it. And then you have kind of things that split up later, things as Gasosaurus and Eurocenturion, Pachycephalosauria, and things like that. So it kind of goes out later, but it is quite late in that group. The Wild Wheat Formation, as I mentioned, was dated about 82 to 77 million years ago, and during that time it would have lived in southern Laramidia, next to the Western Terry Seaway, and lived in quite a rich environment with other dinosaurs such as hadrosaurs like Acrophyseter and Dilophosaurus. Lythronax is another predator it would have lived with, unnamed Ankylosaurs and Pachycephalosaurs as well. Would have lived with lots of fish and mammals and multiple tuberculates and things like that. So it was quite a rich formation found with all sorts of different animals, and we actually have a pretty good idea of what lived in the Wild Wheat Formation, and we actually have a lot of really cool mammals from there as well, which is cool. But yeah, that's Diabloceratops. So that's part of the the lovely bundle that we had come up with, the Ceratopsid bundle by Glitch and Trip. I did a wonderful job with that. So another one we've got by Glitch and Gojira and Chocolate. We have got Gasosaurus. So this one's got a very interesting name as we'll get into and why it has that name. So we'll just wait for them to walk out a bit. Let's have a look at you. I like this one. I like this pose here. It's got a nice pose. So Gasosaurus is actually... Oh, we'll have a look at this one. I like this pose more. I like the color of the other one more, but we'll have a look at this one. So Gasosaurus is a genus of tetranuran theropod that lived about 171 to 161 million years ago, during the middle of the Jurassic. Its name means Gasosaurus is derived from gasoline, and Greek for reptile. So basically the gasoline reptile. Only one species is currently recognized, Gasosaurus constructus, and the name actually honors the gasoline company from the Dashuba Formation quarry in China where it was found, and now named the Lower Shakmo Formation. And the first and to date only fossils, albeit post-cranial missing the skull, were recovered in 1985 during construction of a gas facility, which explains the dinosaur's unusual name. It has teeth, some cervical and dorsal carbovertebrae, humerus, and a lot of bones like the left tibia, left fibia, left femur, left ischium, things like that. So we do have quite a good amount of what it looks like. And it was described as Gasosaurus constructus by paleontologists Dong Ziming and Tang Zilu. And Gasosaurus is a carnivorous theropod with strong arms, strong legs, but short arms. It measured about 3.5 to 4 meters, or 11 to 13 feet in length, and probably would have weighed about 150 kilograms. However, some estimates put it as high as 400 kilograms, so very little is known about it. So it is not that well known in terms of things like that. It is quite well described, though. I'm not going to get into some of the weird features and things like that, but traditionally it was considered to be a megalosaurid. Holtz actually found it to be a basal Silurisaurian and maybe even a basal Carnosaur, potentially a Meteorancid, on basis of undescribed specimens. In fact, may actually be the most basal Silurisaurian known, or maybe a common ancestor to these groups, but definitely represents the oldest definitive tetranuran theropod. So it is quite early in the evolution of these dinosaurs. And some paleontologists have actually speculated that Gasosaurus and Incakujira is actually one of the same species. And based at this fragmentary remains of the known Gasosaurus fossils, it's uncertain position within Tetranura and Laesis. We just really don't know, which is a bit sad. But it lived during the Middle Jurassic, about 164 million years ago, and coexisted with other mid-range theropods such as Dinosaurus and Agujaceratops with a lower maximum formation. And it actually preserves quite a few medium to large bodied theropods as well, and actually has the highest diversity of the Middle Jurassic theropods, which is interesting. And because of that, we don't really know where it's going to place, and it's kind of a bit confusing in all that regard. But yeah, nice, cool Gasosaurus, interesting one that we get to talk about. Really do love like this orange fiery color. It looks quite nice. Definitely did a good job with that. So we'll let them run off and do their thing. We'll spin it up a bit. Let them run off. So next up, we're going for mammals now. We know I love our mammals. How can you not love mammals? So next up, we've got Moeritherium. So let's have a look at these guys. So Moeritherium. And they panic. I don't want them panicking. We'll wait for them to stop. No, we're just gonna wait for them to stop somewhere. There we are. So here's Moeritherium. Let's have a look at this guy. There we are. So Moeritherium is the beast from the lake Moeris, which is an extinct genus of basal proboscidean. So it's an early elephant relative. Comes from the Eocene of North and West Africa. So it's quite an interesting animal. The type specimen was actually discovered in the Kwazulu-Shanga Formation in the Fayum fossil deposits of Egypt, and the type specimen is almost complete mandible, and it was described in 1901 by Charles William Andrews, who suggested it was either part of an obsolete order Amphiphilipoda or an early proboscideid, and it actually kind of referred to an ungulate. But there is actually a couple species described. There were 7 species named, but only 3, which is Lysone, Gracilis, and Charabamaldi, which have actually survived the test of time. So the way they were kind of described and put apart is that Lysone was more gracile but had a larger body size, and they overlap with other ones, so they've all kind of been lumped into those 3. And then kind of at the end of the day kind of got split up. But Harry Fenfield Osborne in 1909 actually suggested these guys were more similar to Sirenians, or manatees and dugongs, rather than elephants. However, he rejected his view and divided Proboscidea into 4 suborders of family: Moeritherium, Dinotherium, Masodontotheria, and Elephantotheria. And these guys are still quite basal. In 2021, there was actually a new species of Dinotherium actually kind of split it up and actually recovered Moeritherium to be still quite basal, but sister to the group that includes Dinotheres and Elephantiforms. So a little bit more, not quite really basal at the tree, but right before we start to get things we kind of recognize as elephants. But yeah, very interesting species. So Moeritherium was actually very small and quite elongate. It was smaller than most proboscidean species. The species M. lysone had a body length of about 230 centimeters, or about 7 feet, and it was only about 70 centimeters tall at the shoulder, and had a body mass of 235 kilograms, or 518 pounds. That they may have had strong size-based sexual dimorphism, but this estimate could be seen as crude average. So in terms of its skull, it had a long, slender skull and very low. The cranial region is nearly twice the length of the facial region, and it actually kind of almost looks more like a siren skull, or something more like a dugong or a manatee rather than an elephant. But unlike larger proboscideans, the nares was quite close to the front of the skull, which is in conjunction with the length of the mandible. Actually suggests that the conventional trunken elephants would have been kind of absent in Moeritherium, instead having a wide mobile unit comprising The nose and upper lip very similar to modern tapirs. That's probably the best comparison to use a tapir-like snout. The external air would have also been quite high in the skull and would have been adapted for semi-aquatic lifestyle. However, it's observed that other proboscideans had likely been aquatic, such as Gomphotherium and Paleomastodon, so it's as much as random adaptation. So Moeritherium itself had large incisors, and the second incisor was modified into short curved tusks. Moeritherium still retained its first and third upper incisors and upper canines in highly reduced form, and seemed to be lophodont, which had large ridges on their kind of lobes or cusp between cusps. And their premolars were actually large and broad in relation to their molars, and a condition that's not seen in later proboscideans, but actually quite similar to manatees. So it's probably a lot of convergent evolution. Because they had that semi-aquatic lifestyle. Postcranial skeleton has actually been compared to animals such as Desmostillions, which is another really interesting group of marine herbivore mammals, which is really interesting. And both taxa have elongated, broad torsos and adaptation for diving, which is interesting. Little of the cervical vertebrae is known, save for the atlas, and most of them seem to be kind of similar to most things. And like modern proboscideans, they have 23 presacral vertebrae, and the lumbar was longer proportionally those in modern proboscideans, but the thoracic region was also slightly shorter. So Moeritherium limbs are also extremely short compared to later taxa, roughly being about half as big proportionally as extant elephants, which are much more land-living animals. And in terms of lifestyle, it suggests these guys would have been fairly aquatic. The notion they would have been semi-aquatic dates as far back as 1909, with Henry Farfield Osborn suggesting that it was not only related to Saurinians but resembled the habitat. And there's been papers kind of indicating the lifestyle, such as the hypercinic ears, things like that. And it's kind of been here, and looking at similarities with Desmostillions and other things actually kind of persist with its life. This animal having a semi-aquatic lifestyle, and was kind of the clincher. Is stable isotope analyses actually kind of led further credence to the semi-aquatic model, with oxygen isotopes actually being more similar to those of aquatic habitats than fully terrestrial ones. So it seems these guys would have been eating freshwater plants, which suggests they would have been semi-aquatic. So that kind of helps with them a lot. But the environment of this formation wherein it lived would have been described as a subtropical to tropical lowland plain, which further suggests the presence of streams and ponds. Based on the occurrence of birds around the area, such as ospreys, flamingos, heron storks, cormorants, and troubles, they would have been living in slow-moving freshwater environments with aquatic vegetation. Although most of these suggest there would have been sandbanks, they also argue that the swamps could easily be formed along the banks of rivers during the Oligocene. And a lot of the fossil birds kind of refer them as well, and could be a more valuable indicator of the species rather than many which belong to family-looking modern examples. The absence of other birds in such environments may be sampling bias, or these groups may have been present in Oligocene Africa yet. But it suggests this area would have been very much slow-moving black waters with plenty of vegetation, other fish living in there as well, and there would have been overgrown potentially with the reeds and papyrus and water lilies, things like that. And there's also a paper that suggests these guys would have had a system that emptied into the Tethys Sea, and it would have been quite monsoonal. But yeah, quite tropical area with lots of water and, places for these guys to swim and eat, which is also quite fun. But yeah, we're going to let them swim off and do their own thing. So, we'll run off and do their own thing, but yeah. That's quite cool. It is a very interesting interpretation. This is a little bit too elephant-like in my opinion, but still a nice mod. I definitely love seeing it. Nice to see Moeritherium. Good excuse to talk about the species. So we'll let them run off. Next up, we're going to... the Moeritherium was done by Jojo Chess. That was a really good addition there. Next up, we've got Hajwak Tree, who did another little bundle. We've got the Miocene Cetacean bundle. We're going to be starting off this little bundle with Acrophyseter. So look at this cool little guy. Let him swim around. Why are you panicking? It's a bit weird. There'll be nothing in here. Whatever. I guess they're just being weird. We'll have a look at one. See if we can spot one that's in a good light. I like this one. Look at this one. I just like the posture it's in. So this is Acrophyseter. So we will go into and then hide. So Acrophyseter is a genus of extinct sperm whale that lived during the late Miocene off the coast of what is now Peru, and is about 2 different species, Dendinodon and Robustus. So these guys are part of an extinct group of macroraptorial sperm whales, and that all share several features for hunting large prey. So basically, that includes like Leviathan, that really big sperm whale, but there was a whole group of sperm whales that were adapted for eating large prey rather than the squid specialized ones that we have today. But these features include deeply rooted and thick teeth. So Acrophyseter itself was on the smaller side, about 4 to 4.5 meters, or 13 to 15 feet long, which made it the smallest macroraptorial sperm whale currently known. And because of its short pointed snout and strongly curved front teeth, it probably fed on marine vertebrates of its time, like seals and other whales. So all known fossils are found from the Pisco Formation in southern Peru. The type species was described in 2008 from a skull and was dated to about 8.5 to 6.7 million years ago during the Torthornian emission stage of the Miocene. And the skull represents a mature individual consisting of its skull and jaw with most of its teeth intact. But in 2017 there was another species described. This one was older, so it's from about 9 million years ago, and consists of a right parietal bone that was recovered as well. And then rocks are younger those of previous meteor locations, and the specimen was dated to 6.7 million years ago. So there's actually some doubts where Dinodon may have actually been an actual species, and actually represents a robustus itself. So there's a bit of confusion there. So yeah, because we know from such few specimens, they've been describing different species, but neither here nor there. But the name Acrophyseter comes from acros, which means acute, which describes its short, pointed, upturned snout, and Physeter, which is the genus name for the modern sperm whale, Physeter macrocephalus. So it's basically the precise sperm whale, and the species name Dinodon comes from basically terrible tooth, and robustus just means robust. So as I mentioned, its body length estimates range from about 4.5 to 4 meters, or about 13 to 15 feet, with a Dinodon being slightly smaller. And using the distance between its cheekbones in comparison to related Zygosphyxida, and actually makes it the smallest species of macroraptorial sperm whale. Okay. Unlike modern sperm whales, they do have teeth in both the upper and lower jaws that are quite deep in their jaws and set in the roots. And they are quite thick and quite conical, which suggests they would have been not eating like modern sperm whales, which are suction feeders. These guys would have been using their teeth and eating more larger, more powerful, thicker prey. A Dinodon has 12 teeth in its upper jaw and 13 in its lower jaw, and which is quite interesting. The last lower tooth may have been contacted the roof of the mouth, and they would have been quite similar to killer whales, which are obviously macro predators. The tooth count of a robustus is unknown, but it's thought to be similar. And these guys would have had stronger teeth, much better biting. And like other sperm whales, they had a deep basin on the top of their skull, the subcranial basin, which would have kind of held the melon. But this orbit did not really extend to the end of the snout, unlike other mactorial sperm whale species. So this suggests they would have had a big melon, but would have also had that long snout, so they wouldn't have that characteristic big boxy sperm whale face. As you can see, it only goes up halfway, and then you have that long snout, which is interesting. And they had the distinct upper curve as well. And unlike later species of sperm whales, they would have had 2 nostrils, with the left nostril being 5 times larger than the right one, measuring about 30 or 7.2 centimeters, or about 1.8 to 2 inches, respectively, which is quite interesting. In terms of its taxonomy, it is belongs to a group of macropredatory sperm whales, together with Leviathan, Brigmophyseter, and Zygophyseter, and with all having large, deep-rooted teeth covered in enamel that were adapted for hunting large prey. Macropredator sperm whales are either thought to evolve these adaptations from a basilisaurid-like ancestor, or individually evolved it twice in this group, which is quite interesting. And there's extinct a family, Hotacellae, which has been proposed to hold this group and have other species. However, this grouping is actually paraphyletic, which means they do not have a common. Does not include ancestors and all its common descendants. So it could potentially be a lot of convergent evolution for these groups evolving to be large and attack large prey. So in terms of its paleobiology, as I mentioned, features like their short snout and things like that means it targeted large prey, and they would be eating large vertebrates. And in terms of the habitat it lived in a lot of very interesting animals, such as whales such as Piscobalaena, dolphins like Arctocetus and Brachydelphus, the seal Acrophoca, or the long-necked seal, penguins such as the kind of Spedivus urbani and Amazoni, which are kind of modern relatives of like the Humboldt penguins and things like that. Those penguins that live in South America. The marine sloth Thalassocnus, the Piscogravelus, which is an extinct species of marine gharial, and Megalodon, everyone's favorite Megalodon, and broad-toothed makos. Though it seems these guys, being much smaller, they would have been preying on small species, not really competing with the big boys up top, you know? They can't really do that. But yeah, we'll let them swim off and do their thing. Nice one to talk about. And we've got another one from the Miocene. We've got a filter-feeding whale this time. We have got Incakujira. See if we can get a good pose out of here. I like that pose. That's a nice pose. Alright. Okay. So this is Incakujira, which means the Incan whale. These are a genus of rockwool whale that lived along the coast of Peru about 8 million to 7.3 million years ago. It consists of two species, Incakujira Anto de Fuego and Fordyce. And the type species which is Anto de Fuego, which was found in 2016, and then the second species was described in 2024, with all known specimens coming from the Pisco Formation, the same formation as Acrophyseter, which dates back to the late Miocene. And how we distinguish it from other rock walls, it has a less attenuated rostrum and features of the maxilla, suborbital, and remainder of the cranium. So it is a way to tell them apart. And Kujira is a genus name, means whale in Japanese. So it's basically the Incan whale, but the whale is in Japanese. And what kind of interesting sets this guy apart is the twisted postulatal process of the squamosal suggests these guys would have been lunge feeding. Were not as great as those of extant rock walls, and that it would have itself also pursued additional krill feeding strategies like skimming. So they wouldn't have been like lunge feeding like things like fin whales and humpback whales and blue whales use. They weren't quite well adapted for that yet, but they were getting on their way, and they would have been using like skim feeding, which is quite interesting. But yeah, really, really cool. Do love these guys. Another really, really cool whale that we get to talk about. Not too much different from this guy of other whales, but we'll let them swim off and do their thing. But next up, we've got not necessarily a species, but a very interesting specimen. So those two whales were done by Harsquark Tree. This one's done by Trippy. We all know love Trippy, who's done a lot of mods today. We have got the Aust Colossus. Yeah, this is a very big one today. Let them swim and get a good look. Look at that one. Look at that there. Well, that's a nice pose. I like that one. Anyway, the Aust Colossus itself was an unnamed genus of ichthyosaur that lived, well, it's unnamed now, I'll get into that, but it was found in the late Jurassic of the United Kingdom. So in 1850, there was a large Jurassic bone from the Aust Colossus in Gloucestershire in United Kingdom was described alongside other fragmentary bones, with 2 are missing, primarily destroyed, but they were originally identified as limbs of sauropods or stegosaurs. However, they were actually likely mandibular elements or the lower jaw of ichthyosaurs. And Dean Lomax suggested that one of these os bones was a subangular of a similar animal that may be even larger than Ichthyotitan, which was a giant 25-meter long or 82 feet long ichthyosaur that was previously identified as the livestock monster. And scaling off Ichthyotitan, the Aust Colossus would have been about 175 tons and 29.3 meters long, or 96 feet 1 inch, and it would have been potentially about 290 tons, so potentially rivaling blue whales and things like that. Though I highly doubt they would have been that big. But as I mentioned, Ichthyotitan was an extinct genus of I've covered Ichthyotitan before, but this is like a particular specimen that could have been much larger. It is believed to be a Gasosaur, so related to things like Dinosaurs, and these guys would have been living in England during the latest of the Jurassic, so kind of goes with the trend of the biggest things being in the late Jurassic. And it contains a single species, Ichthyotitan sevenensis, which is known from 2 fragmentary subangular bones that were found in 2016 and 2020. And being that they're just very small bones, well, not small, but fragmentary, these estimates can't be really well, described, but they estimate the body length of Ichthyotitan to be about 25 meters long, which would make it the largest marine reptile currently known. So, yeah, there's been quite a few. The Aust Colossus was not described as a specimen of Ichthyotitan, though it very likely could be. Though there's quite a few things like that around. So it's mainly based off the livestock monster, which is actually believed to be still growing. So it's possible that the Aust Colossus could be an adult form of this. Another possible remains, as I mentioned, there's the Cure specimen that was found as well. So it would take a lot of figuring out because there's a lot of very fragmentary remains. They could all be part of Ichthyotitan, including, as I mentioned, the Aust Colossus, which is interesting, with other possible remains. And as being a Chastisaurid, and it's actually the only giant ichthyosaur known from the Reptilian, which is right at the end of the Jurassic. So this would have been before the extinction, so they basically would have got as big as they could, and then those big ones would have gone extinct during the Jurassic extinction, and then would have become pretty much, the ichthyosaurs that we're more familiar with. And size estimates very hard to calculate. As I mentioned, the 2024 study suggests that these guys, Ichthyotitan specimen, the BAS specimen, could have been potentially 25 meters, and the Aust specimen would have been potentially larger at even 30 to 35 meters, so pretty much rivaling blue whales in length. Maybe not in weight, but length, which is quite interesting. And they seem to be quite similar to Dinosaurs, though there would have been some differences, of course, because they're different species. The Aust bones actually believed to be present in the livestock with actually poor preservation. And the unique pairs of peristernal growth is actually believed to have a role in accommodating the biological size limits of these invertebrates. So they actually may have been repeating, potentially getting as big as they could get. So that's quite interesting. And in terms of paleoecology, these guys would have been potentially originally identified as suction feeders, but we do know they would have had large teeth, and we do have some specimens of Dinosaurs with robust teeth, the gut contents of mollusk shells and vertebrates, so they likely would have been predators, very much like a giant sperm whale or orca. They would have been taking advantage of the richness of marine food webs. Though the Jurassic, actually, this would have been when plankton would have become quite common, and these guys would have been flourishing, so, plankton, the base of the ecosystem, and then kind of built up, and these guys would have been the top of the ecosystem, eating a lot of things. But yeah, really, really cool. Nice to see the Aust Colossus, another really cool mod. So, yeah, I think this is actually a great place to end today. A really interesting assortment of beasties, especially some marine ones. I always like talking about marine ones. But, yeah, I think this is a great place to end the video, so I really, really, really hope you guys have enjoyed this video. Hope you guys like and subscribe. Always remember to hit the little bell icon to get notified about anything. So if you guys enjoyed this video, hope you guys like and subscribe, and bye-bye.